let's start now with the development of those DBT models. If we go back to the initial lessons, right? DBT sits on top of our platform, BigQuery or Postgres, depending on how you're doing the course. And we loaded already the stored data as the trips data all. We have the green data, yellow data as well. And now we're going to do the development and the testing and documentation. So we're going to do these 2 layers in something like a sandbox. And then at the very end of these lessons, we are going to deploy that into production in order to use those transformations in our BI tools. Something that we need to understand to get started, we're going to be using a modular data modeling approach. As we saw in the first lessons, we are going to be doing something like fact tables, dimensional tables, and the way this is going to look in our DBT project is following a structure similar like this. We're going to first have those tables that we loaded. That would be the trips data. All those are our sources. And then we're going to start building this SQL scripts that we're going to call models in DBT that are going to be doing transformations. So let's say we pick up that data, and then at the very beginning, we're going to have in a script where we're going to clean that data. We're going to deduplicate. We're going to recast it, rename it, typecast it as well. And then we're going to have another saying that's applying the business logic. So let's say making those fact and dim tables. And we're going to later on make something like a data mart, aggregate the data to serve to our stakeholders. How is that going to look like in each SQL file? So let's think about the anatomy of a DBT model. As I said, these models are SQL scripts. So we're of course going to be always working with a file that has the name of the model, that's the name of the file, and it's a SQL file. And in there, we're going to be writing our SQL statement. What we're actually going to be writing is the select statement because DBT is going to be doing that DDL and DML for us. But we have to tell DBT how to create that DDL and DML. And for that, we're going to be using something like this. So if you see here, I'm telling DBT that this my model.sql has to be materialized as a table into the database. This is going to tell DBT how I want to compile that code. So when I do a DBT run, what it's going to do is going to pick up all the SQL files that are within my project, and it's going to compile all that code, and it's going to look something like this. Create table, under my schema, my model, name of the file, as, and then the same select statement. There are different materializations that we're going to be able to use. This is something that we're going to be seeing as we create those models, but you should know that there are mainly 4 types. The first one, and easiest, is ephemeral. These are not models that do not really materialize in a physical storage. That means it's a model that can only really live within other models, something similar like a CTE if you're very used to write SQL. Then there's a view. A view is going to materialize in the database as a view. Every time I do a DBT run, it's going to create or alter that view as select statement that is within our file. Then there's a table, which is materializes as a table in the physical database. And every time we run it, it's going to drop the table and recreate it, create table, select as we saw in the previous slide. And the last one, very interesting, a little bit more advanced usage, is incremental. Incremental is going to be materialized as a table within the physical storage, but every time we run it, there are going to be 2 ways of running it. One is create the table, drop the table, create the table with the select statement. And the second one is insert only the new data into the table. So how is all of this going to look like in our project specifically? As I said, we initially have those tables that already exist from outside of our DBT project, and those are the data. Those have the data that we're going to use. So we're going to define those as sources. We also are going to use a file, which is going to be taxi zone lookup as well, that we're going to use to create a table that we then are going to use for our transformations. So we first are going to select from sources. This is the data that we loaded already, and we're going to define it in a YAML file where we're going to tell DBT where to go find that source. This allows us to define that location only once and then be able to define all of the tables that are within that location under that definition. This also allows us to abstract a little bit the complexity of where is that source physically stored, because we only define it once, and then every time we call it with something like this, right? It's a source, the function, and then the name that we put to the source definition, and then the name of our source table. This is going to then be compiled to the location that we have defined here. It's going to use this database and this is schema. Let's move this here. And something also nice that we can do with DBT is that when we use sources, then we also open the possibility of doing a lot of testing within those sources. One very important that we're going to get started with is freshness. So we can define something like a threshold to test the freshness of our source. This is going to be very convenient when we have a pipeline, an ongoing pipeline in production. When we are working in a company, it's very important to know before the stakeholders tell us that our data is not fresh. With source freshness, we would define the threshold that we're willing to let it be, which is okay and acceptable, and alert us if the data is older than that threshold. This can also allow us to use things like selection. So we could potentially select only the DBT models that depend on fresher data as well. We're going to also see, as we see tests, that we're going to be able to apply a lot of this DBT concepts also to sources. So all of that is going to allow us to have a better data quality in our models because we're checking those sources. The second thing we're going to select from are seeds. Seeds are CSV files that are stored in our repository. If you are familiar with SQL, what DBT is going to do when you do a DBT run of a seed is doing something similar to a copy into command. The benefit of using a seed within DBT is that it's going to lie in a repository along with every other file that confirms your DBT project. And that means that it brings a lot of the benefits that DBT projects have. So it's going to be version control. You're going to have it in one single repository shared. You can document it and you can test it as well. And you can run it along with your whole project. This is recommended usually for data that doesn't change frequently. We're going to use it for a master data table, taxi zone lookup. It's something that it's not huge. So it's nice to have it in there and being able to benefit from the version controlling. The other thing that we can select from, if we go back to the modular, let's say we have the sources and then we created something that cleans the green trip data, something that cleans the yellow trip data. And then we're finally ready to do those fact models or dimensional models. In those cases, we're going to be selecting different DBT models. So in that case, we're going to use this ref function, and this is going to allow us to reference to those underlying tables. And if you see, I just put here the name of the model that I want to work with, and it is going to compile this into the location where it's going to go. This allows us to run the same code within any environment. This means when I'm working on this, this is going to my name, so DBT underscore Victoria schema, but when we are running this in production, this is going to go to something like production. And DBT abstracts all of that complexity from our responsibilities and allows us to just run the same code everywhere. This ref is also going to bring us a second benefit, which means it's going to build automatically the dependencies, because now it knows that the second DBT model depends on the station green trip data, and that is going to help us a lot along the development. Let's go and try to the IDE, and let's go to our project, which is new and ready to start. We have here our project. Here is the folder. Here is the project YML. We changed the name to taxi, and we are ready to start. Let's go and define under the models. Let's create a folder. The station, that's how we are going to name that initial layer of models that are cleaning the source data. And under station, let's create a file. Let's put sources.yaml. We're going to be doing this, by the way, this project, so you can follow along. See, station actually is a schema.yaml, and we're going to be following all of this code, so you can also copy paste from these places. Schema.yaml. Let's do that. Every YAML starts with this version 2, so then DT can compile it. And what we're going to do here is define sources. If you see it's auto-completing, the IDE is auto-completing a lot of the stuff that I need to do. We're going to name the sources a station. And what we actually need to define is the database, where this is coming from, and the schema. You're going to be able to define this here. So this is the database. Note that this, because I saw that this was confusing, and it is because this is normally called a database for every other data warehouse, data platform, but BigQuery calls this dataset. So we're using the same config that DBT has for every platform, but there's a bit of a mismatch in there. So know that when we talk about database, we're actually, in DBT, we're actually talking about datasets in BigQuery, but in reality it's databases in every other place but BigQuery. So this is my database. I hope that wasn't too confusing. Database. That's the name. Let's go schema. My schema is this one, where I have my data. So trips underscore data all. And then what we're going to define is the tables. So the tables that I want to use are green trip data, yellow trip data. Oh, yellow trip data. You saw already that it's telling me to generate a model, so we're actually going to use that. We're going to try it out. This already also gave me a start to build this lineage of those two tables. So as sources, that means that I can use them in models in DBT. We're going to be working with the green, so let's start with the green. Good. So it's created under models, station green trip data. We're going to change that once we save it. I want to make sure that we follow the same project as we have, but let's see what is this doing. So this is a with statement, so it starts as a select, no DDL, no DML, good. And it says select everything from, and it's using here the source, and it's correctly calling a station, which is the name that I defined here, and green trip data, which is the name of the table. I want to clarify what I briefly mentioned during the slides as well. Something important here is that because here I'm using a name, I could actually change this. Let's say I could now switch to Postgres and just change the name to the one I'm using in Postgres and change the schema. And this is going to affect all of the models that are using like this, but I do not have to change that code. I only change it here. So this is very cool. This is the do not repeat yourself concept, right? And right now it's only really one file, but you can imagine that I could use this source in many, many places, and that would, and many, many tables as well, right? I could have under this source, which is how real life projects look like. So this simplifies a lot of the refactoring. Whenever you're changing platforms, you're changing schemas and naming conventions. Cool. So now that we have this, let's save this. And let's try to use the same. I'll show you what I'm doing. I want to have everything under that station. This is troubleshooting and I want to make sure that I renaming this as the same here. So I want to make sure that it's called like this: station green trip data. Rename station green trip data. Okay, we're ready to go. And what it's going to do afterwards is select from this source, select everything from rename. So we're going to be changing some of that stuff, but let's just build. Let's just build the whole project. So I could build from here, but let's try to build the whole project because I know we still have the examples. So I want to show you what's going to happen now. DBT, when it's doing build, it's picking up all of the models, all of the tests, everything that I have defined within my project, and it's going to execute those things in order. So we see here that it picked up 7 things. Let's make this. And one is my first DBT model. The other one is my new model that I just created, which is a view. And it's under my schema, DBT Victoria, call with the name of my model. And then it's taking other stuff. It's taking a test, which is failing. So then it's skipping because it failed. It's skipping the others that depend on my first model. So it's skipping my second DBT model. We're not going to care about those because we're going to delete them. But I want to show you how I start thinking about how DBT executes those models. In fact, let's delete those now. Those examples, and let's continue. What we're going to do now is learn a little bit about macros. So you started to notice that I've been using within a lot of places this things with 2 curly brackets like this, right? Like source, we saw it in the ref as well. We saw it when we were talking about materializations. That means that we are using here a macro. And in fact, there are different things how we can use those curly brackets. We could use them like this. So one curly bracket only and then one symbol. See, here is a different symbol. Or we could use 2 curly brackets. All of that we're going to use within the curly brackets, that's Xinxia. Xinxia is a templating language. It's similar to Python in terms of how it's written. And it's going to allow us to tell DBT how to compile the code, as I said before. So with Xinxia, we're going to create macros. And macros are like functions that are going to allow us to generate code. So unlike the functions that we saw before in Python and JavaScript, or even in SQL, the difference here with the macros is they do not really have an input and an output. They have an input and they do have an output, but that generates code. They are going to be very helpful for us. A lot of those are already part of DBT. Things like the source and the ref. There's Xinxia behind that you can see because this is open source. But it's also going to allow us to create our own macros. And that is going to help us a lot to simplify the code. Because first of all, we could abstract pieces of code that we use in multiple places, allows us to use the do not repeat yourself concept again. But it's also going to allow us to generate dynamically code. So think about using a for loop, for example, to generate a case statement. We're going to use something simpler for now. We're going to create a macro that we're going to call get payment type description. And if you see, it's very similar how you would define a function in Python, because think about this as like the def function. Here is the name and here's the variable. And then inside here, we're going to put the code that we want to take out from from the macro. And if you see here, I have the payment type, which is the input variable, the parameter, and then here I'm calling the parameter. So what I'm really going to do is just take that code out and put it in a macro, so then I can reuse it in multiple places. And then this is really a case statement. And then we're going to call it like this, get payment type description, payment type. And you see it's similar to a function. This is the parameter. And then once we compile it, it's going to generate a case statement for us. So let's start to do that. And our IDE. So we're going to go macros, create file, get payment type description, .sql. There are also SQL files, as you see. We're going to generate the macro. Let's just copy the code. Let's copy the code, but let's see then what it's doing. So first of all, when I'm doing here, this is clearly a comment, so I can put something. This returns the description of a payment type. Then again, we write macro, the name of the macro, the parameter, and then we just have this. This because it's between the two curly brackets, it's going to print whatever we put in payment type. This means, here I use payment type everywhere, but this means that I could use this in a different table where the field for payment type, it's called banana, and then I could just send banana in here as a payment type parameter, and then this would make the case statement saying case cast banana as integer, and then put the case statement in there. So that is pretty cool, right? Let's save this and let's actually try to use this under staging trip, green trip data. So here we have payment type. Let's get payment type description. Sorry, this is a macro, so let's just there it goes. Get payment type description, and let's just send payment type as, and let's put payment type descripted. For now, we're going to fix that afterwards, but I just want to show you how this works. I'm actually going to compile this. When we compile, we get to see what DUT is going to run. So what we do is we are avoiding wasting those credits and allow us to see what it's going to run. So here, select from, we knew this, match, right, trips, data, all. And then in here, as you see, cast, oh, very important, that was a string. Payment type, let's do the compilation again. Payment type as integer, and what it's going to do is, right, when it's 1, 2, 3, 4, 5, 6, it's going to do something. If not, it's going to give us empty. Good. The nice thing about macros as well is that, or Shinsha, is that similar to functions, if I define a function that I really want to use it a lot and I actually want to use outside in another projects, I can make a library. In DUT, I can also do something like that, and I can do a package. So let's go next one, and I can write a package. So this acts like libraries in other programming languages, and these are really just DUT projects that have models, that have macros, that are helping us with that part of the code so we don't have to write it. By adding a package to our project, we are able now to call it within all of our project in any place. So we just need to go create this packages.yaml file, and in there we import it. There's a lot. We can use our own projects, so we could just put here the GitHub or like the Git URL, but lucky for us, there are a lot of packages that are already made in the package hub. And then one thing before we go there, the way I would call it is DUT utils. For example, here I'm importing, right, the DUT utils, and then I just call it DUT utils dot and the function macro that I want to use from there. So we're going to see how to use packages for macros, but there are other things that we could use. So know that there's a lot of things that are going to save a lot of your time. So if we go to the package hub, have it here open, there are a lot of things. There are also packages that are not necessarily published because, as I said, you could use something like an internal package, an internal DT project as your package. So imagine in your company, you generate a lot of macros, a lot of this payment type, for example, macro. This is something that it could help a lot of like other data teams as well. So I could just abstract that and create a package internally. We are going to use DBT utils. These are the most used packages. And we're going to use DBT utils, which has a lot of very interesting functions, macros, tests as well. But there are a lot of this. So think about, for example, something for sources. Fivetran has a lot for different sources. So if you're bringing data from Instagram, maybe you want to import this package in this bills project already start. If you want to use the metadata from your DBT runs, then there are a lot of packages for doing that as well. And that would help you a lot to get started. Let's go to DBT utils and let's actually go to the repository. I like going to that repository because then I always know if there are like issues, pull request, latest versions. You don't need to, you can also do that from the hub. But you can see actually from the hub, I wanted to show you one more thing. In the hub, you know exactly how you would install it. So we can take this. And here, what is nice from the repository is that you get to see the actual code, how it's being resolved. So for example, we are going to use, there are a lot of like SQL generators. We're going to use one that it's called surrogate key. We're going to do this generate surrogate key, and you can, as I was saying, you can go to the actual code of the macro. So you could even copy, paste the macro and generate a version of your own of this. Let's go to the IDE. Let's create the packages.yaml. Oh, here under the main, under like the home of the DBT project, right? So it has to be at the same level as the project.yaml. Packages.yaml. Yeah, let's do that. That's it. It should be triggering. It didn't do it, but let's run it ourselves. Usually this is done automatically as soon as you log in. So if I were to log out and were to log in, this is usually running DBT deps. What DBT deps is doing is installing those dependencies, installing everything that we brought there from the packages.yaml. We can see here, install DBT labs, DBT utils from this version. Nice. We could even see here under DBT packages that it brought the packages, it brought the macros and everything. As I said, we're going to use that surrogate key thing, so we can see here how it's used. So I just call it like this, and then in the middle I can put which are the fields that I want to use to be doing that surrogate key. And what it's really doing at the end, we're going to see when we compile it, but it's going to do a hash of those files. Let's go back here. Let's go to green trip data. Let's put that as the beginning because the surrogate key is usually, you usually want to put the identifiers at the very beginning of your table, so then you know at the very, when I open this, I know exactly what is the granularity of my table. That's a good practice. And we're going to do this surrogate key with vendor ID. This is like the taxi, and then the pickup data, because each vendor can only pick up one person at the time. So that's a good surrogate key. That's it. Okay, and let's keep this a number. Let's do this trip ID as a number. And that's it. We could compile this. We could see exactly how it looks like. See, 2 hex, and it's applying really an MD5. of those two fields. And MD5 here that I'm using BigQuery, it can change depending on your platform. That's also the nice thing about macros and the adapters that DVT is using, is that it's going to be changing the code whenever I'm changing the adapter. So now when I go to Postgres, this function will look slightly different. That's because, right, it's going to be adapting, but I don't really see the difference, so it's abstracting that complexity for me. Good. Do we want to build this? And I think after this, we're pretty much ready to move on. Let's see. It went fine. It created the view. Under details, you can also see create the view as with my data, all of this here. You can also see all that code under the target folder, by the way, under compile. You'll always be able to see what has been running. This can be very helpful. As you see, I did already example, but it's maintaining the information from my runs in this session in the IDE. So this can also be very helpful if you're having errors, troubleshoot, then you just come here, take that code, take it over there to your BigQuery, for example. And talking about BigQuery, we've already been running a lot of things. Let's refresh this. And we should be able, yeah. Well, this had some more stuff that I was trying, but this is really my model. Staging green trip data that we've been working with, has the trip ID, and this is what my run just executed. So I think we are not ready to copy paste the code entirely from our repository. And we're going to see what's different from here, because a lot of the things have really just SQL, so we're not going to talk about those. But something we're going to talk about, first of all, we find now that we have a config file. A config macro. So this is something that could be interesting for you to know. Let's delete that. Whenever I'm trying to write my DBT models, if I do __, this is going to help me, and it's going to help us given the Shinsha blocks. And let's put view here. You may have noticed I didn't really have this before, and it was working fine, and it was making a view. So why do we have this here? You don't need to have it. By default, everything will be a view. You could alter that default in the project YML. So you could say, make everything within my project materialize as a table, or you could even do that by folders. You could say, make everything under station a view, make everything under core a table. This is usually by default. This is usually how those projects look like in production. And whenever in a model I define a config, then this will override the default. So let's just leave the view here. Just know that sometimes it's nice to have this as well, so then I know that I purposely chose this to be a view. And let's see what else is doing. So here in the first initial CTE where I'm selecting data from the source, it has now a row number. I am using the same two fields that I used to generate the zero key, which means I'm trying to find duplicates of that primary key, of rows that have the same primary key. And then I can filter by those that have row number equal 1. So then I only maintain one of those duplicates. Something else that's happening here is that the vendor ID, we're cleaning it to make sure that we don't bring any null data. We have here our zero key that we created before. I added some comments as well to keep our code in order. There's some casting, a lot of casting being done, some renaming, and here, of course, is our payment type. But now there's something else that we have here. And this is what we're going to learn now. This is variables. The concept of variables is very similar. It's the same as any programming language, right? So if you're not familiar with it, a variable can act similar as a bucket, where you put some value, you store something that you want to use, and then you can take it, you always have it available to take it away from that bucket whenever you need it to use. in DBT, we can define those variables at a project level. We can define those variables within the project YML and then use it in different places. So let's see here, I have payment type values defined, and I have a list of numbers. So I could use this in different places. For example, in the case statement, I could do a for loop that makes sure that it goes through this list to build a case, or I could even use to test it to compare against the actual values that I get the table. Are those within the list or not? And another way could be using that variable, defining that variable with this macro, the bar macro. I could set dynamically a value within my macro, for example. And another third way to use it is defining the value of that variable within my execution. So I can pass a value for that variable in the command that I'm running. And I can always call that variable using the bar macro. So here, let's go to the code. Let's see if we're in there. So here, what I'll be doing is if. So I have here a conditional execution if the variable, and when I do if and a value, that means if it's true, then do a limit 100. If this is false, then do nothing, right? Exits the if because there's no else. And let's look at this now specifically. So it's calling the variable isTestRun, and it's adding a default value equal true. This means if I have a value for isTestRun, it's going to use that value. That could be true or false because it's a Boolean. But if there's no value for isTestRun, use true by default, meaning by default, always add a limit 100 to our code. And let's just run the code as it is. And let's make sure we see that limit 100. We could compile the code as well for here. Let's do, okay, station trip data. Let's go to details. And let's see here what it's doing. Create or replace my view. All of the code that we already know because we've run this many times. The macro resolve, and then it's adding the limit 100. This is very important because a lot of people get confused with this, with the homework. So if you're still watching at this video, now you know, you won't be tricked. And let's take this now. And let's say I don't want to have a limit 100. So let's do duty build -- select station green trip data. Bars, and we're sending a dictionary. So within those variables, we're sending those in a dictionary. I can send many variables at once to be used during my execution. And I'm saying isTestRun equals false. So whenever I'm doing this, then what it's doing, what we expect this to be doing, is to not add the limit 100. And indeed, it did not add. It added the comment, which is fine because it's a SQL comment. It did not add the 100. This is a very useful macro, by the way. Like you could build this as a macro and then, or just copy paste this piece of code in your models. This is very useful. This is called dev limit. Highly recommend it because this will allow us, but by default, we'll have cheaper queries because they'll be limited to 100. It will be faster, it will be cheaper. And when we actually want to use all of the production data, most likely in deployment, this will proactively put the isTestRun to false. Good. So we have now a lot of things done. We are going to create the other. We're going to create, remember that we want to do a station, create a file, a station yellow trip data. This is more or less the same, so we're not really going to see how that looks like. I'm just going to copy my code and we'll follow. It's very, very similar, the code. It uses the same macro. It has some difference because they're always straight scaled and it doesn't really have the same variables. but code itself, SQL itself is pretty much the same. And now we're going to move one layer. Something that when we did that, right, it generated this lineage. So far our project, let's delete and see the whole project. Our project looks something like this. We have our two sources and we have a piece of models here. And remember, we need to now create our fact and dimensional tables. So we're going to come here. We're going to create a core, and we're going to go ahead and create that dim zones. Our problem is not a problem, but we want to make sure that we have as well when creating dim zones is something like a master data table. Let's do dim zones.sql. What I want to have here in dim zones is all of the zone data from the places where those taxes are moving. So those taxes are always moving within a zone, and we want to make sure that we have information regarding that. So for that, we do not really have source data, so we're going to use the seeds that I mentioned in the past. So we're going to have this taxes zone lookup. This is perfect because it doesn't really have that many records. It only has like a few hundred, 266, and it doesn't really have that many columns. It's something that won't change much. It's very, very unlikely that Queens is not going to be called Queens anytime soon. So at most, we just may add zones whenever the taxes are getting to more places. I'll show you something how to copy this. Go to row, and that's it. Let's take all of this. And let's actually create this here under seeds. Create a file. This is called how is this called? Taxes zone lookup CSV. By the way, you could, this is within the trip data, this file, so you could actually download this, import this in the GitHub, completely valid. Let's create this. Let's save this. I'm not so sure about this thing is working correctly, but let's do this. And if you see, the seed has like a nice plant icon. Okay, it worked. It created a seed file under DBT Victoria taxes zone lookup. We could even find it here if we were to do a refresh. Under Victoria taxes zone lookup as a table. Let's do a preview of the data. Looks fine. If you see here is the location ID. If you remember, maybe not, all good. The location ID is within the green and the yellow trip data. So what we're going to be doing is, for other models, encasing that data with this. So what that location ID looks like. So let's go back here and let's go under models again. Let's go core and let's just copy paste the dim zones. What this is going to do in the, under the dim zones really, well, we can also write this code ourselves. So let's just, what this is doing is selecting from, this could be a good example anyways, from that taxi lookup, right? Taxes zone lookup. And we could even do a preview of this. And this will allow us to work with that project, with that table and create those things, right, that we want to do, which are the names of, so we want to do location ID, bureau zone, and then service zone, and then location ID, bureau zone, service zone. And something that we had is that within service zone, there was a problem where everything that was borrowed was actually green zones. That's a place where only the green taxes go, so we're just going to rename it so then it's easier for our analytics. So let's just do this, or we do a replacement, we clean a little bit this data, let's save this, and that's it, we're ready with the dim zones. And what we're going to do now next is create a fact table, a fact trips table. So let's just create another type. Let's do fact trips.sql. And what we want to make sure we do here is, let's go back to lineage, let's delete everything. What we want to do under fact trips is we want to make sure that we take both the green and the yellow trip data, we put that data together and we encase it using the zones data. So we'll put all of that together under fact trips. And if you saw, fact trips is empty, so now it's like here alone. But we'll add it here using those ref. So something that we want to make sure is this is a table, because this is going to be a bigger table. This is going to be a model that's going to take longer to run because it's union things, it's joining. So by materializing this as a table, we are making our queries more efficient, but also more performant. When we suppose, the closer we go to the BI, something that you should know, the closer we go to the BI tool, the more performant it should be. We should make sure that we're making this persistent because the stakeholders are going to complain if it takes a long time. Let's go here. Let's bring both green trip data and yellow trip data. Select. Let's take everything from. You can also do this as well as I showed you before, reft, and then because it auto completes, let's do this. Yeah, staging trip data. We also want to make sure that we add something to identify, because we want to be able to identify green from yellow for our analytics, right? So let's add a green as service type from. Good. We'll do the same with the yellow data. Yellow trip data as same. Select star, comma, yellow as service type from. Let's do the ref. Yellow. That's nicer. And what we're going to do next is union all of this. So let's do a trips union as and purposely both modules had the same structure. That was part of the cleaning. Remember that we did something like adding a 1, for example, to add an extra field. So this is going to work perfectly once we run it. Let's do union. Let's do union all. Feel free to copy paste this. And what we want to make sure next is that we also add the zones. As select from theme zones. Perfect. Remember that there were a lot of, if we were to the theme zones, let's do the preview. There were a lot of unknown zones. We want to make sure we don't take those. Like if it's unknown, we don't want to know. Like whatever doesn't join with them zones will be unknown as far as it concerns us. So let's do Borek is not unknown. Good. Now we finally could join this. all of this. So let's do, I'll copy paste the fields for now, but let's do a select for now from trips union inner join. We want to be sure we only keep those things that have zones, so inner join dim zones as, let's rename this as the pickup zone. Because one thing, when we are in staging green tree data, and the same will happen with yellow, we actually have two location ID. One is the pickup and one is the drop off. So we want both to be shown with dim zones in order to show for both pickup and drop off the name of the zone ID. So let's do inner join dim zones of pickup zone on trips union dot pickup location ID equals pickup zone location ID, and then this is really the same. Let's do that twice. Trips unions, let's do this drop-off zone. Drop-off zone. Good. What this is going to also make is if a tree doesn't have a valid zone that we don't know the name of, it's going to be lost, right? We just have all of this running. So let's try to build this and hopefully it works. But because dim zones will have the same trip ID as this other two, let's just go ahead and copy factory string here, and let's just do a real select. Select IDE. Let's not do this. Let's do all of this. Now we save, and now we build. Something very cool is that we could do build. Let's go to lineage actually. Let's see. Now it looks a little bit more like the modular that we were talking about before, modular data modeling that we were talking about before, and now we see factories depends on all of this, right? So something that's pretty cool here is that because DBT has identified all these places, all these connections, we could say run factories, but first run all of the children, all of the parents. So DBT would test the sources for freshness or for anything else, will run all of those things. That means refreshing or building them if they don't exist, or can do fact trips at the very end. So the way we can do that is using this plus. So this will do build plus at the beginning, plus at the end is everything. So parents and children. In this case, we don't have children yet, but let's just do that. And then there's only really one more model that we're going to do, and then we'll be done. Good. Run correctly. Fact trips, everything is here. So we do have at first try to do station trip data, station yellow trip data, taxi lookup. Then it does dim zones as well, and then it does fact trips. And then fact trips created a table. See here that's telling me that it's processing 19.2. And I have everything in here. By default, I'm just doing 100. So this is exactly where we're trying to limit with those 100 to make sure that we're not picking up the whole amount of data. So you understand. And so if you want to do the whole thing with all the data in production, as I said before, were very important for the homework, then you'll have to do, how was that? Bars is let's go to the comment to trick this. Bars is test run false. Two bonds false. And this will run the whole project. Well, everything before unfolds. So with all of that production data. This is how we're going to do it in deployment, by the way. And good. And indeed, no 100. And the fun tricks should be a little bit more than the 19 gigabytes that we saw before. There it goes. Well, I guess it's the same because it's caching. But you can see here that here it only really had 197, and here we do have 62.7 million rows that are being processed to have this fact trips. So we're ready now to go and test these models to make sure that when we deliver those 70 million rows, those are correctly.